Welcome back. Let us go through the question. Two wires of diameter 0.25 centimeter, one made of steel and other made of brass, are loaded as shown in the following figure. The unloaded length of steel wire is 1.5 meter and that of brass wire is 1 meter. Compute the elongations of the steel and the brass wires. Tension in the steel wire is F1. So F1 is 4 plus 6 into 9.8, which is coming out to be 98 Newton. Length of steel wire small L1 is 1.5 meter. The diameter of the steel wire small d is 0.25 centimeter. Now the cross-sectional area is determined by pi d by 2 whole squared. So if we put the value of d here, we can get the cross-sectional area to be 4.9 into 10 to the power minus 6 meter square. So area of the steel wire A is 4.9 into 10 to the power minus 6 meter square. Let the elongation in the steel wire be delta small l1. Young's modulus of steel y1 equals 2 into 10 to the power 11 Newton per meter square. Capital Y1, that is Young's modulus, is F1L1 divided by delta L1 into A. So from this particular formula, we can find out the value of delta L1. So putting all these values, we get it to be 1.5 into 10 to the power minus 4 meter. So tension tension in the bars where F is F2. Now F2 is 6 into 9 into 9.8, that is 58.98 Newton. Length of brass wire, that is denoted by L2, is 1.5 meter. Area of the brass wire cross-sectional area is 4.9 into 10 to the power minus 6 meter square. Let the elongation in the steel wire be delta L2. So likewise, we get the value of delta L2 as F2 L2 divided by Y2 into A, and it is coming out to be 1.32 into 10 to the power minus 4 meter.